In this video, I put together the 12 best examples of how to identify the asymptotes of a rational expression from a playlist with over 100 different videos. We're going to talk about how to identify the vertical asymptotes, the horizontal asymptotes, the slant asymptotes, as well as holes. So therefore, you have a better understanding of not being able to just identify the asymptotes, but also be able to graph a rational expression. All these examples from basic to more advanced are included in this video, and I hope you enjoy. Cheers.
So when dealing with a rational function, which we could call r of x, and we'd have n of x over d of x, which basically means a rational function is we're going to have a function in the numerator and a different function in the denominator. We can look at those functions as a to the x to the m plus dot, 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 over b to the x to the n plus dot, 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 dot. It really doesn't matter, but remember in Algebra 2 and even Algebra 1 we talked about, or Algebra 2 at least, we talked about taking a polynomial and rewriting it in standard form, meaning that you're going to have your largest degree first and then going down in descending order, right? And then you identify the leading coefficient and the degree. So assuming that I have my two functions, we want to make sure that they're in standard form, where a and b represent the leading coefficient and m and n represent the degree. So when you guys look at this polynomial, you'll see that both of these are written in standard form, right? Where the degrees are both 1, and my leading coefficients are 1 and 7. Does everybody follow me with that? Okay, so as long as my rational function is in that form, there's some tests for horizontal asymptotes. The horizontal asymptotes, if m is less than n, then y equals 0 is your horizontal asymptote. If m is greater than n, there is no horizontal asymptote. And if m is equal to n, then y equals a over b is your horizontal asymptote. That's the horizontal asymptote test. So we look at this. We know that m and n represent our degrees. Our two degrees are 1 and 1. Well, those degrees are exactly the same. So the horizontal asymptote is going to be the quotient of your leading coefficients, which are a and b. Well, a represents the leading coefficient of the numerator. B represents the leading coefficient of the denominator. So therefore, you can see that my horizontal asymptote in this case is y equals 7 over 1, which is y equals 7 is my horizontal asymptote. Remember when we're doing rational functions. And the one thing I started off this instruction with was how to find the vertical asymptote. And that's all I taught you guys. That's all we went over with this graph. I did give you guys an equation. Actually, I'm not sure if I left it out for this class. Y equals n of x over d of x. OK, but I didn't get to explain really anything else. I just said, ladies and gentlemen, rational expressions aren't the reciprocal function. They're related. But basically, you're going to have a polynomial up top and a polynomial on the bottom. OK? That's what it looks like. So you can see this follows along. What's nice about this one, though, it's already factored, right? They already factored it for you. So that was nice of them. Then the other thing that I left in there before we ended class is I said to find the vertical asymptote, you set the denominator equal to 0, then you solve. So if you wanted to find the discontinuities, you might not understand what that is. But if anything, all I really expect you guys to do is to find the vertical asymptote of every single graph, or every single problem. So if you found the vertical asymptote, you would have said x plus 3 equals 0. Subtract 3, x equals negative 3. And based on what you were taught last class period, that would have been OK. I would accept you to do that for every single problem, because that's all I had time to teach you guys. However, now we have a little bit more time. We can get into removable and non-removable discontinuities, because mathematically, this is not a part of the domain. However, it's not an asymptote actually in this case. This is actually not an asymptote. So whatever, my definition is still the same. To find the vertical asymptote, set the denominator equal to 0. However, ladies and gentlemen, what you should see is we can apply the division property, right? If you apply the division property, the x plus 3's divide out, leaving us with just x minus 4. right? Well, but still, and that's a line, so that looks something like this. But still, x cannot equal -3. Well, lines don't have asymptotes, right? We don't have asymptotes. So how do we graph something, a line, but have x cannot equal -3? What that is called is a hole. So the graph is still a line, but originally you have a removable discontinuity. So when you have a removable discontinuity, you'd still set the denominator equal to 0 and find it. But it's not going to be an asymptote like my previous definition. When it's removable, meaning you can divide it into 1, it's called a hole. And graphically, it would look like this. Okay? So the difference of your discontinuities, you either have an asymptote or a hole. If it's something that can be factored and simplified out, it's called removable. Because do you guys see how we removed the x plus 3's? So it's removable. When it's removable, it's called a hole. If it's non-removable, it's an asymptote. And you would create a nice little dotted line.
So would be an example of being
We'll do that next. But again, the domain is still the same thing. Domain is all real numbers such that x cannot equal the discontinuity, which is still the same. X can't equal -3, right? So that doesn't change. The range doesn't change. Just think of it like an asymptote. It's all real numbers except y cannot equal. Now, we do need to figure out what that, at x equals -3, we need to figure out what that would be. So if you plug in -3 in for that, -3 minus 4 would be -7. So such that y cannot equal -7. Because we need to figure out what would the y value be at x equals -3. And then we need to find the x and the y intercepts.
That's the only part of that equation I can do.
So x-intercepts, y equals 0. 0 equals, you could do it for either one. It doesn't really matter, x minus 4. So you get x equals 4. And you could write that as a coordinate point as 4, 0. To find the y-intercept, x equals 0, y equals -4, 0, -4. And that was it. And does that look like that's roughly about right? Yep. And that's all you guys had to do for that. All right, so in this case, again, your homework is being very nice to you. It's already factored, right? So we don't need to worry about factoring. But however, you might have a problem where you'd have to factor it first. But this is already factored, so we see, is there any removable discontinuities? No, nothing's removable. So therefore, we know that our discontinuities are going to be non-removable, and therefore they're going to be asymptotes. Because if they're removable, they would be holes. So to find the vertical asymptotes, very simple. All we do is set our denominator equal to 0. And fortunately for us, we studied quadratics. So remember, when you have a factor, two factors set equal to 0, we can apply the zero product property to solve. And using some algebra, I have two asymptotes at 3 and -4/5. You don't have to graph it, but visually, if you want to just kind of understand what that would look like, something like that. All right, we're not going to graph it. It's not asking us to graph it. But you guys know there's two asymptotes there, right? Correct? And that's all they're really asking us to do, is to find the asymptotes. So those are your two asymptotes.
So what would that graph look like?
It's
Yeah, that doesn't even make sense.
there's a lot of different ways we could do the graphs. In this one, I'd have to we would find the vertical asymptotes, then we find the horizontal asymptotes, and then what we would do is if you're asked to graph and you don't have a graphing calculator, what's the best and easiest way to make a graph? Create a table. So what I would do is I would find the horizontal asymptote, and then what I usually choose, I'll explain that. We haven't taught it yet. Then what I would do is choose 2 points to the left of the asymptote, 2 points to the right of each asymptote, plug those values in for x, and find y. And what you'll do is you'll see that there's a graph to show. But that's all you guys had to do for here, is just find the asymptotes. So what they're asking us for this one is they're not asking us to graph it. But all they're asking us to do is find the removable discontinuities, non-removable discontinuities, our vertical asymptote, or horizontal asymptote, our domain, and our range. So for this, remember, removable discontinuities are going to be our discontinuities that we can factor out. Our non-removable are going to be our discontinuities that we cannot factor out, right? So let's go and take a look at this. First thing, we want to see what are discontinuities. Our discontinuities, remember, are going to be our where our values are going to be not defined in our denominator. So the first thing I can always determine is, what is my vertical asymptote, right? I always think that was always the easiest thing to be able to figure out. So I could do that equals 3x squared plus 8, equals 0, right? To find your vertical asymptote, or our discontinuities, we want to figure out, actually, I'm sorry. But before I go to that, I look at this. Is there anything I can factor out in the numerator or in the denominator? No. So right now, I can't factor anything out. So therefore, removable discontinuities are not going to apply as far as I'm concerned right now looking at this graph. I can't see anything I can factor out. So Sadiq, that'd be very important for you to know to start off with. Now I want to be able to find my vertical asymptote. So I take my denominator and I set it equal to 0. All right, so I look at this. I have a quadratic, but I only have one squared term. I like having a quadratic with only one squared term because then I can apply the square root method, right? You can try to factor this by doing a times c, and then my middle term would be 0, right? If you're going to use the diamond problem, you do 3 times 8 over 0. But I don't really want to go through factoring. I can solve this by the square root method. I can subtract the 8. Since I only have one x term, I can just use inverse operations, which we call the square root method. So we look at this, and we have x equals plus or minus negative square root of negative 8/3. Can you take the square root of a negative number? No, you can't take the square root of a negative number. So therefore, it doesn't make sense. Oh, well, we can, and it's an imaginary, right? It's I, right? So does it make sense then for me to graph my asymptote with I? No, that's not going to have a physical presence on our graph with real numbers, right? So our vertical asymptote, do we have a vertical asymptote right now that exists? No, right? So vertical asymptote, you can just say it's not there, not applicable. All right, we don't have one. Because when we try to find the vertical asymptote, it's imaginary. So your vertical asymptote is imaginary. So therefore, we're not going to have a vertical asymptote. So therefore, do we have any discontinuities? Do we have any values that we cannot be? And no. And think about that, guys. Look at our denominator. Doesn't matter what number I plug in for x. Is there ever going to be a problem for it to be 0? No, right? No matter what number you plug in there, this is never, ever going to be 0. So therefore, we do not have any discontinuities. So when it asks for removable discontinuities, they're not applicable. Non-removable, not applicable, because you're never, ever going to get 0 in the denominator. No matter what number you plug in here, you never, ever will get 0. OK? Yes, Ashley? Got it? OK, good. So now let's go and look at the domain. So if the domain, if there's no discontinuities, our domain is going to be all real Alex numbers. There we go. Good. Now let's go and look at our range, though. All right. So our range, we need to look at our horizontal asymptote. So remember, the horizontal asymptote, we had a couple rules, right? The horizontal asymptote says there's a couple rules. When our degree, which in this one is 1, when the degree in the numerator is less than the degree of the denominator, does anybody remember, Sarah, what the horizontal asymptote is? Y equals 0. Great. Okay, and then if that was flip-flopped around, then we know that we'd have to, we say there'd be no horizontal asymptote. Unless the difference was 1, then we could go and look for a slant asymptote. And if they're exactly the same, then we could take the leading coefficients of both, divide them, and that's the one, right? You guys got to know this for your test, right? All right, so we have the horizontal asymptote is y equals 0. So therefore, if I want to find the range of this function, the range is just going to be all real numbers except y cannot equal 0. There you go. Any questions on 20? Any last thing? Good? OK. OK. So let's go through this problem. On this one, for this problem, I asked you to find all intercepts, right? And I asked you to find all the x and y intercepts. So Jacob, what you're going to want to do, can we all come in agreement, ladies and gentlemen, when I ask you to do this on your quiz, because you have your 4 answers or your 4 problems, when I ask you to do this, can we all come in agreement to find the vertical asymptote first? Okay, let's all do that. So the vertical asymptote, I'm just going to represent with V. The vertical asymptote, remember, is going to be all the values of your variable that make your denominator equal to 0. Because remember, we can't divide to 0. Okay, Marco? And so since we can't divide by 0, we need to find the values that are going to make our denominator 0. So what I do is I take my denominator, say x squared plus 9 equals 0. Now, I solve for x. Subtract 9 on both sides. X squared equals negative 9. Square root. X equals plus or minus the square root of negative 9. We understand, though, that the square root of negative 9, remember that we had the principal square root property. We're going to take out the negative. That means we're going to have I. Remember, I is going to represent imaginary numbers. So do we have a real x-intercept that we could graph? No. So for vertical, I'm sorry, not x-intercept. For an asymptote, we don't have any. So we're just going to say none. So there are no vertical asymptotes for this problem. Now, the next thing is let's look at horizontal asymptotes. So the horizontal asymptotes, ladies and gentlemen, there's a test. It's called the horizontal asymptote test. And what we do for the horizontal asymptote test is we take a look at the exponents, or the degrees of your two polynomials, right? Remember, a rational function, the rational functions that we're going to be dealing with in this class is one polynomial over another polynomial. Polynomials all have a degree. And the degree, remember, is your largest exponent of your variable. So what we look at, n is going to be the exponent of my numerator. N will be the degree, which will be the largest exponent, the degree of my polynomial in the numerator. And m is going to be the degree of my polynomial in the denominator. So if n is less than m, we have a horizontal asymptote at y equals 0. If n is equal to m, we have a horizontal asymptote of the leading coefficients of your numerator divided by your denominator. And if n is greater than m, we have a horizontal asymptote at nothing. We do not have a horizontal asymptote. So we look at here and we look at our degrees. The degrees for both polynomials is 2. So therefore, we're going to be dealing with this situation, right? So therefore, my horizontal asymptote is you take your leading coefficients of 1 and 1, and you divide them. Okay? So my horizontal asymptote is equal to y equals 1. Follow me so far? We good? Okay. So that's to find the vertical and the horizontal asymptotes. Now I'm going to erase this because the next thing we need to do is the next thing I asked you to find the x and y intercepts. So there's two other terms for this, x and y intercepts. To find the x-intercept is when y, or your f of x, equals 0. And your y-intercept is when x equals 0. So x-intercept is when your output value equals 0. So we just put a 0 in for that, and we get x squared over x squared plus 9. In contrary, the y-intercept is when x equals 0, so it looks like this. F of x equals 0 squared over 0 squared plus 9. All right? So now we just need to evaluate. Remember, how do we get rid of a denominator? When we have a fraction, Michael, we multiply by x squared plus 9. Therefore, we get 0 equals x squared. Take the root. X equals 0. Cool? So therefore, we can say the x-intercept is equal to 0. And then I asked for the y-intercept. Well, we evaluate 0 over 9, 0. Okay? And that's all I asked for that one problem, right? X-intercepts and vertical and horizontal asymptotes. So again, your vertical asymptote was none because we had to take the square root of a negative number. Horizontal asymptote was the ratio of your leading coefficients, which was 1. And then our x-intercept was at 0. And my y-intercept, or my y-intercept, or the f of x-intercept, is going to equal 0. Any questions on what I did? Nope. You guys are going to do this for every single problem. If I said, listen, if I have 3 equals 1/4 x, right? How do I get rid of the 1/4? You multiply by what? 4. Because what happens? The 4 divided by 4 gives you 1. And you're just left with x equals 4 times 3, right? Same thing. Whatever's on the denominator, what's x squared plus 9 divided by x squared plus 9? 1. So it just goes down to 1, so we're just left with the x squared. Okay, so whenever you have something on the denominator, that's what you want to multiply by. Okay? And just make sure you do it on both sides. So the first thing we want to look at is on this horizontal asymptote, right? And again, by the horizontal asymptote test, what we want to do is we see, oh, the highest power in the numerator, which is the degree, is the same as the highest power in the denominator, which is the degree, right? So since they're equal to each other, we look at now their leading coefficients. I don't have a leading coefficient here, so it's a 1, right? So my horizontal asymptote is just the ratio of my leading coefficient over my leading coefficient. Y equals 2 over 1, which is just equal to 2. That easy. Vertical asymptote. Vertical asymptote is going back to chapter 1. What do we do? Oh, we set the denominator equal to 0. So we have x squared plus 2x minus 3 equals 0. Oh, looks like a nice little factoring problem. X, let's see, we're going to do minus 1 times x plus 3. Let's see, does that work? Looks good to me, right? So therefore, I have an x vertical at x equals 1 and x equals negative 3. Now, so I found the asymptotes. I found the asymptotes. Now that 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 I found the asymptotes, I can now move to the x-intercept. The x-intercept, remember we talked about, guys, was basically you're going to get the same thing. You're always going to multiply the denominator on both sides. So just set the numerator equal to 0. I could divide by 2 and take the square root. But I think at this point in this game, you guys know that x is going to equal 0. For the y-intercept, I could plug 0 in for x and solve for y. But what I notice, it's going to be constant over constant. I don't have a constant here, so I can use 0. So what happens when I have 0 equals over 3? Which is just equal to 0. Okay? Ladies and gentlemen, there's one thing I want you guys to understand or get very, very used to. Any single time you guys see a trinomial or you looks like a binomial, looks like something should be factored, we always want to make sure we just factor it. Doesn't even matter if it's a part of the problem or not. Let's factor this. This is going to be x minus 2 times x minus 1, or sorry, x plus 1, all over x minus 3. Now, this is very important because they're asking us to find the asymptotes, right? Let's just pretend I could use the division property and divide this out. If I divide this out, let's just pretend this was an x minus 3 as well. If I could divide that out, that's no longer an asymptote anymore. That's now a whole, right? So if you can divide out your terms, it creates a whole. It's still a discontinuity, but it's a whole, not an asymptote. So that's very, very important because when we're finding the asymptotes, if we have a whole, that's not an asymptote. However, we factor it out. Nothing else can be simplified. So all we need to do, just like we did for the domain, is set your denominator equal to 0. Because where your asymptotes are, those are the values that are not in your domain. So set it and solve x equals 3. Done. Vertical asymptote. Next one. Horizontal asymptote. Horizontal asymptote is, again, we need to compare the degree and the numerator. I'm sorry, the degree in the numerator and the denominator. OK? What you guys can see is the degree in the numerator is greater than the degree in the denominator. So based on your horizontal asymptote test, which we did in the first quarter, Logan, do you remember what the horizontal asymptote is when the degree in the numerator is greater than the degree in the denominator? Nope, you're going to want to make sure you have that because I quizzed you and it was on your test, and now it's going to be on this one again. There is none. Every single time. Doesn't matter what the degrees are. Every single time the degree in the numerator is greater than the degree in the denominator, you do not have a horizontal asymptote. But that does now allow us to have a slant asymptote. So since there's no horizontal asymptote, we're going to find a slant asymptote. And all you guys need to do to find the slant asymptote is just use long division. In this case, yes, we could do synthetic division. But I just want to go over long division again to make sure that we are on the same page. So how many times is x going to x squared? X times. X times x is x squared. X times negative 3x is a negative 3x. Subtract the rows. X squared minus x squared is 0. Negative x minus negative 3x minus a double negative is positive. So that's really negative x minus negative 3x, which is 2x. X goes into 2x how many times? 2 times. 2 times x is 2x. 2 times negative 3 is negative 6. Bring down the negative 2. And it really doesn't matter from here. You're going to get 0, and you're going to get 4, which is your remainder. However, I will tell you, don't worry about 4. X doesn't divide into 4. So don't worry about your remainder, ladies and gentlemen. It doesn't matter. Your slant asymptote is simply the quotient of the division. That's your slant asymptote. So don't worry if it has a remainder or not. So let's take a look at this problem, see what we can do for it, and see if I can help you guys out with this one. So what we have here is we have f of x equals 2x squared minus 5x plus 3 divided by x cubed minus 2x squared minus x plus 2. So ladies and gentlemen, as I mentioned before, the easiest and first thing I want you to do is find the vertical asymptote. Remember, the vertical asymptote is when the values of x that make our denominator 0. So all I'm going to do is I'm going to take my denominator, and I'm going to set it equal to 0. 0 equals x cubed minus 2x squared minus x plus 2. And then you might be like, oh, crap, so how do I find the values of x now? Well, you got to look at our techniques. It's not a linear equation, so you just can't solve for x. You have multiple x's, and when you have 4 terms, a factoring technique we use when you have 4 terms is factoring by grouping. So what you're going to want to do is group the first 2 terms and group the last 2 terms. Then factor out separately. So 0 equals x squared times x minus 2. Here I can factor out a negative 1, so therefore x minus 2. Does everybody follow me with the grouping? Remember this from old school? Then we have 0 equals x minus 2. I factor that out, so I have x squared minus 1. Now, the reason why we use factor by grouping, one, I can group those 2, factor it out. Now I can use the 0 product property, and I could say 0 equals x minus 2, and 0 equals x squared minus 1. So my vertical asymptotes, which I'm actually going to write up here, because I'm going to have to erase this. My vertical asymptotes are when x equals positive 2 and 1 and negative 1. As I solve, I add 1 to the other side, take the square root. I get plus and minus 1. All right, any questions with that? That was your vertical asymptotes. So x equals 2, x equals plus or minus 1. Cool with that? That's your hardest factoring problem. The rest of them out of your homework are either you can solve just by solving an equation, or you can solve by factoring a trinomial, so forth. So the next thing I need to do is determine, I'll do horizontal here next, while some of you are writing this down. So the next thing is horizontal. So the horizontal, I have to use my horizontal 0 test. Remember, the horizontal 0 test tells you to compare your exponents. So I make sure that my polynomials are in descending order, with the highest degree first and then in descending order. And what I notice is my degrees, which is 2 and a 3, since the degree in my numerator is less than the degree in my denominator, right, we have a horizontal asymptote at y equals 0. All right? So that's it. Just by using that test, no mathematics. Or algebra needs to be used. OK, so you have y equals 0 as your horizontal asymptote, and vertical asymptote is x equals 2, 1, and negative 1. Now the next thing we need to do is it says to find the x-intercept. So remember, in those other problems we worked with, x-intercept is when your f of x equals 0. So what I'm going to do is I'm going to say 0 equals 2x squared minus 5x plus 3 divided by x cubed minus 2x squared minus x plus 2. And remember, we talked about this. How do we get a fraction off our, the bottom of the denominator? You have to multiply it on both sides. So I'm just going to write it really quick. You multiply that on both sides. This whole expression multiplied by 0 is just going to become 0. And then obviously, that divided by itself is just going to give you 1. So you're just left with 2x squared minus 5x plus 3. Then you got to say, all right, geez, now what I got to do? I got to make sure I multiply or see if I can factor this. So you need to look at this and say, what two terms are going to multiply to give me, 6. So I need to look at this and need to say 2x times x. And they need to multiply to give me 3. Or look up there and give me 3. So it'd be, I'm not seeing that's factorable. So then what I'll look, I'm sorry? But the only problem with negative 3 and negative 1. Actually, no, wait. Could you do negative 1 and negative? Let's do this. Negative 1 and negative 3. Yeah. Well, I was thinking about switching them the other way. That's what I was looking at. But that will work, right? Yep, that works. There you go. Equals 0. So therefore, your x-intercepts are going to be now. So now you say 2x minus 3 equals 0, and x minus 1 equals 0. So now you could say x equals 3/2, and x equals 1. What's up? Remember, you're multiplying these, right? 2x times x is 2x squared, right? Negative 3 times negative 1 is positive 3. 2x times negative 1 is a negative 2x. Negative 3 times x is a negative 3x. Negative 2x minus 3x is negative 5x. Okay? So are we cool with the x-intercepts? Because we now need to do the y-intercepts. Actually, we can do y-intercepts right here. I want to do them below. So we could say the x-intercepts. X-intercepts are when x equals 3/2 and when x equals 1. So the last thing we need to do is now determine the y-intercepts. So to determine the y-intercepts, that's when x equals 0. So all we do now is plug in 0 in for x. So you do 2 times 0 squared minus 5 times 0 plus 3 all over 0 cubed minus 2 times 0 squared minus 0 plus 2. 0, 0, 0, 0, 0. F of x equals 3/2. So to finish off the rest of this problem, you can say your y-intercept, which I didn't leave room for. Your y-intercept is when f of x equals 3/2. Any questions on this? No? Good? Maybe? All right, so what I'm going to do is I'm going to show you how to find the vertical and the horizontal asymptotes of a given function. So the first thing we want to do is when we're finding our vertical asymptote, our vertical asymptote is going to tell us pretty much what values of our function are not going to cross on the x-axis. So what it's very similar to is actually finding the domain. And if you remember, when you have a rational function, to find the domain, you determine what values make it 0 on the bottom. And whatever values make it 0 are not going to be a part of your domain. And that's the same thing with the vertical asymptote, because if you think of a vertical asymptote, it's going to be a number, it's a vertical line that it's a value of x that your graph does not have or is not defined for. So to determine this, I'm going to set each one of my values. So when I want to find my vertical
vertical asymptote, what I'm going to do is I'm going to set the bottom equal to 0 for each problem. And this is just very similar to like finding the domain. And the reason why is, remember, whatever values make it 0, that's not part of my domain. And since it's not part of my domain, it's not an x value in my function, or my function is not defined for that value. Therefore, it's called what we call an asymptote. And meaning an asymptote is when you look at a graph, the graph is never going to have a value at that point. And we'll get into it when we talk about graphing. You guys will see what I'm talking about. So here, I'm just going to add 3. X squared equals 3. Square root. X equals plus or minus 3. I'm sorry, square root of 3.
Yeah.
Right? So therefore, my vertical asymptote for this problem, that means the x values are x equals plus or minus the square root of 3. So we'll get into graphing later. Here, to find the vertical asymptotes, I set it equal to 0. And here, since I have a trinomial, I can't do adding to the other side. When I have a trinomial, I'm going to look for factoring. And I see that this can be easily factored into x plus 6 and x plus 1 equals 0. Therefore, my asymptotes are x equals negative 6 and x equals negative 1. I'll just try to make it a little bit quicker. Remember, just set each one of those equally to 0, and then you solve, right? Okay. Here, this one's very easy. I already know that x equals x is 0 as my vertical asymptote. So the next one is we need to look at our horizontal. It's very hard to write with a pen like this, or at least upside down. So when you want to find your horizontal asymptote, what we need to do is we're going to look at, there's two things. We need to look at our leading coefficient. So we need to compare our leading coefficients and degrees. So when you guys look at each one of these problems, we need to look at the leading coefficient and the degree of our leading term. So here, of each polynomial. So of the top and on the bottom. So you compare leading coefficient and degrees for your polynomial up top and polynomial at the bottom. Here we have a polynomial, but it's a constant polynomial. Now, a lot of you might say, well, there's no x right there, right? Well, I can put x to the 0 power, because any number anything raised to the 0 power equals 1, right? 1 times 3 would be 3. So then the next thing I want to do is I want to compare my degrees, all right? And when my degree up top is less than the bottom, so when 0 is less than 2, the top is less than the bottom, right, of your degrees, my horizontal asymptote is going to be y equals 0. And I'm saying y because, this is your y-axis and that's your x-axis. So my y value is going to equal 0. All right? 0. So whenever your top degree is less than your bottom degree, your leading coefficient, how am I doing that over there? Y is equal to 0. Okay? Next one. What?
Is that because you divided 0 by 2? Or,
No. It's just whenever. It doesn't matter if that was 1 and that was 3.
Okay.
Whenever you have a top is smaller than your bottom degree, it's always just y equals 0.
Okay.
Always. So it doesn't matter if it's 5 and 50.
Okay.
It's 0, it's less than, so y equals 0. Now, when you have that equal, okay, what you do is you take the number in front, which there's no number in front of here, right? So we write 1. You take the number in front and you divide them. So whenever they're equal, so when you say like the top is equal to the bottom, what we do is we take our coefficients and we divide them. So we say y equals 1 over 1, which is 1 in this case. Does that make sense? So whenever they're equal, so if this was like a 3/4, then it'd be 3/4, right?
So just always divide the coefficients. And then, now when we can put a 1 there. Whenever we have the top is larger than the bottom, so you can say the top is larger than the bottom, there is no horizontal asymptote. No horizontal asymptote. And that means there's going to be a slant, which we'll show in another video. But if you guys can just remember, whenever the top degree is smaller than the bottom degree of your leading term, then your horizontal asymptote will be y equals 0. When they're equal, you take the two coefficients and you divide them. And here, 1 divided by 1 is 1. And here, whenever it's larger than the bottom, there's no horizontal asymptotes. And that's how you find the horizontal and the vertical asymptotes. So let's talk about vertical. All right, so we're talking about our horizontal asymptote was our horizontal line, right, that our graph approached. Our vertical asymptote is going to be now the vertical line that our graph is going to approach. And remember, when we talked about vertical asymptotes, or on our notes, we talked about our domain. And the domain, remember, is the set of all x values that make up your function. When dealing with rational function, your domain is going to be all real numbers. All real numbers for your domain. All right? For the functions we're going to be dealing with, it's always going to be all real numbers. The next thing to notice, though, please, it's going to be all real numbers except when your denominator, it's going to be except for the values of x that are going to make your denominator equal to 0. Okay? It's going to be all the values that are going to make your denominator equal to 0. So to find the vertical asymptote, so horizontal, well, we had to do the test, right? We had to compare the degrees. It's either greater than, less than, or equal to, right? For vertical, all we do is we take our denominator and we set it equal to 0. All right? So you set it equal to 0 and solve, and that's it. So to find the vertical asymptote, you just take what's on the bottom and solve. So let's get to the first one. The first one, you could multiply that out, but you guys notice this is actually what we can use the square root property. Just take the square root of both sides. So you have x plus 1 equals 0. So x equals negative 1. Undid the square root on both sides. So I can say my vertical asymptote is when x equals negative 1, right? Because x equals negative 1 is a vertical line. If you graph that, x equals negative 1, that's a vertical line. Yes, yes, yes. Yes?
Why did you change it to a positive?
That's what I was thinking.
I don't know. What are you talking about? I didn't change it to a positive. Sorry, I'm maybe losing it. But does that make sense what I did? Okay? So I square root of both sides, get rid of the square. Now for this one, I have a trinomial. So what technique do we use when we have this quadratic? Rhymes with tactoring. Factoring, right? Oh my God, we passed out the test and you wouldn't believe how many students forgot how to factor. So can we factor this? Yes, we can. X plus 3 times x minus 2. Now, why do we factor? The only reason why we factor is when factoring, we get rid of our x squared, but then we can now use the zero product property. So you can say x plus 3 equals 0, x minus 2 equals 0. X equals negative 3, x equals 2. So now your vertical asymptotes are when x equals negative 3 and x equals 2. Does that make sense? So now this graph's actually going to have two vertical asymptotes. So your graph's going to approach both of those lines as it goes to infinity and negative infinity.
What does it look like?
We're going to talk. We'll look at them later in class today. And the last one is this one. So now we say, all right, we got to do this by what? Factoring, right? Is this factorable? No, right? So since it's not factorable, well, how else can we find x? Well, it is set it to 0. So what techniques else can we use? If it's not factorable, then we can use the quadratic formula or complete the square. Either one. since I have a positive 1, I know I'm going to have to divide by 2 and square it. I'm probably not going to want to complete the square just because I don't want to deal with fractions. So what I'm going to do is I'll use the quadratic formula. So it's negative 1 plus or minus the square root of 1 squared minus 4 times a times c, all divided by 2 times 1. Okay? So when we look at this, we have negative 4 times negative 1, which is going to be 5. So we have x equals, so negative 1, let's see, that's going to be negative 1, so plus 1, so it's going to be square root of 5 over 2. All right? That's plus or minus. Okay, I can't reduce that anymore, the square root of 5, so I'm going to actually have 2 y-intercepts, or 2 vertical asymptotes at negative 1 plus square root of 5 over 2, and negative 1 minus square root of 5 over 2. All right? So now we just don't have real numbers. They're going to be imaginary numbers. If you guys want to plug them in, you'll get a decimal, right, for your value, an irrational decimal. But those are going to be your vertical asymptotes. Okay? So, ladies and gentlemen, let's talk a little bit about domain then, just real quick. Remember, I talked about domain is going to be all real numbers except when our x is, or when our denominator is 0. So when is our denominator equal to 0 for the first one? When x equals 1. So you can say your domain, you don't have to do this, but it's important for you guys to know your domain is from negative infinity to 1, union 1 to infinity. You could say all real numbers where x does not equal 1, right? You could say from negative infinity to infinity where x does not equal 1. You could say all real numbers except x cannot equal 1. You can, just different values. Here, you're actually going to have 2 of them, right? You'd have to do it twice. You say from negative infinity and then does not equal negative 3 and cannot equal 2. And from here, it's negative infinity to infinity, but x cannot equal negative 1 plus square root of 5 divided by 2, and negative 1 minus square root of 5 divided by 2. All right? We understand at least what the domain and vertical asymptotes? Kind of? OK. All right. So for this one, again, ladies and gentlemen, we would just want to find. Now, this one was a little bit different. We are going to, I asked you to find all the intercepts and then do some solution points, right? I'm sorry, not the intercepts. I asked you to do all the asymptotes and then find your solution points, right? So what we're going to do is I'm just going to show you, we will do the intercepts again, but I'll do that after the video just to kind of keep this video a little bit short. So the first thing, again, the first asymptote we always want to find is the what? Vertical. So remember, vertical is going to determine what is going to make our denominator 0. So we set our denominator then equal to 0 because we want to find the values that make it equal to 0. Well, in the last problem, we could just solve for x here, right? But now we have a quadratic with two different variable or 2 x terms. I can't just put x on the side and take the square root. I have to use a factoring technique. So I'm going to factor out an x. And I get x times x minus 1 equals 0. Now I can use the 0 product property to say x equals 0 and x minus 1 equals 0. Therefore, my vertical asymptotes are when x equals 0 and when x equals 1. Right? Except for 1. Now, let's find the horizontal, right? Because we just want to go in order, vertical, horizontal. And I'm not going to write down the whole vertical or the horizontal test because what we notice is our exponent up top is larger than the exponent in the denominator, right? Our degree up top is larger than the degree on the bottom. So we have, say, n is larger than m. So by using your horizontal asymptote test, you need to know that there is no horizontal asymptote when your degree in the numerator is larger than the degree in the denominator. Right? Yes? OK. So now when we don't have a horizontal asymptote, that now creates an opportunity for us to find an oblique or slant asymptote. So how do we find that? Well, we're going to have to provide long division. So the first thing we're going to do is write x squared. Actually, this is, so I write x squared minus x cubed plus 0x squared plus 0x minus 1. I'm going to put the zeros as placeholders. Remember when I first did long division? It helps so you guys don't make mistakes. So x squared goes into x cubed how many times? X times, right? Multiply, you get x cubed. X times x gives you negative, or x times negative x gives you negative x squared. And then we could do plus 0 x and then plus 0, because we don't have terms for there. So we subtract the top from the bottom. X squared minus x squared is 0x cubed. I'm sorry, x cubed minus x cubed is 0x cubed. It goes to 0, right? X squared minus a negative x squared, I'm sorry, 0x squared minus a negative x squared now gives you a positive x squared, because that's a 0, right? And then we have 0x squared minus 0x squared. That's obviously going to go to 0. And then negative 1 minus 0 would give you negative 1. So now I say, does x squared go into x squared? Yes, it does, one time. 1 times x squared is x squared. I guess I could say, just put those coefficients there. 1 times x squared is x squared. 1 times negative x is a negative x. Subtract. X squared minus x squared is 0x squared. 0 minus the negative x squared is negative x, or positive x minus 1. Does x squared go into x? No. So that's now going to be our remainder. Okay? Guys, again, I'm not going to get too detailed into this. Once this gets bigger, though, as my numbers get larger, what gets larger faster, the numerator or the denominator? The denominator, right? Because you're always going to be squaring, right? So this is going to get bigger, much faster than that's going to get bigger. So as you have a denominator that keeps on getting bigger and bigger, what does this whole number approach? 0, right? So since it approaches 0, it actually is not going to affect my slant asymptote.
Teachers, party interruption. Teachers, seniors have been released from the gymnasium back to class. They have been instructed that they have 3 minutes to return to class. Please mark them tardy if they are not back in class in 3 minutes from now. Again, seniors have been released from the gymnasium. They are instructed to return to class within 3 minutes. Mark them tardy if they are not back within 3 minutes. Thank you. Have a good day.
Okay. So you guys see how we get there? So your slant asymptote, all you're going to do is you're going to take your quotient, not dealing with your remainder, because your remainder actually, it goes to 0. And that's going to be your slant asymptote, y equals x plus 1. Make sense? With your asymptotes, we'll talk about solution points next. Cool? Any questions? No preguntas. Okay. You don't do anything different. First thing you always want to do is the vertical asymptotes. And just because I think vertical asymptotes are the easiest. Factor, and then make sure you don't have any holes, and then just set the denominator equal to 0. However, is there anything that we can multiply to give us negative 7 that's going to add to give us negative 3? No, so that's not factorable. So I know obviously that's not going to divide out. So my vertical asymptote is just x plus 3 equals 0. So x equals negative 3. Done. Horizontal asymptote. Again, you're comparing the degrees. Actually, I like doing green with these. So guys, we already did this. We did when the degree is greater than the degree in the numerator, then y equals 0. When the degree is equal to the numerator, y equals a over b, which is leading coefficient over leading coefficient. Now we have an example of the degree in the denominator is less than the degree in the numerator. So there is not a horizontal asymptote in this case. But you guys need to make sure you can distinguish all of these. Okay? Know when they occur, know how to find them. But now, since we do not have a horizontal asymptote, we now have a slant asymptote. So how are we going to define the slant asymptote? Well, all we simply do, and the reason why slant asymptotes come, I think they're actually the easiest to remember, is because x plus 3 divides into that, right? This is a smaller degree than that. So what we can do is do long division. In this example, you actually could do synthetic division actually too, right? But majority of the problems a lot of times you have to do long division. So we're just going to practice long division. So again, let's go through long division step by step again. How many times does x divide into x squared? X times, because x times x gives you x squared. X times 3 gives you 3x. Then we subtract the rows. X squared minus x squared is 0. Negative 3x minus 3x. So if you owe me $3 and you borrow $3 more, you now owe me $6. So negative 6x. Now, how many times does x divide into negative 6x? Negative 6 times. Negative 6 times x is a negative 6x. Actually, let's do that green. Negative 6 times 3 is a negative 18. Bring down the negative 7. Subtract your rows. That becomes a plus, so that's 11. And that's your remainder. However, yes? How many times does x go into negative 6x? Negative 6 times. Then remember, you take that negative 6. I didn't. I did negative 3x minus 3x. Is negative 6x. Right. Now, it's really important for you guys to understand. Diana, close that. Really, really important for you guys to understand. Once you apply long division, your slant asymptote is your quotient, not dealing with your remainder. I don't want to mathematically get into it, but this goes to 0. Okay? So your slant asymptote is going to be y equals what the quotient is, which in this case is x minus 6. Okay?